This is video number 3 for sections 4.4 and 4.5, an application problem using a table. All right, we're going to consider now an application problem using the skills that we've been learning. This one concerns a stock account. So the value of Ellie's stock was $3,000 in 2005, and then the value of the stock has doubled every 4 years since. Here's our handy let statement that we always look for. V in this problem, otherwise known as f of t, is going to stand for the value of the stock in dollars. T is going to stand for the number of years since the year 2000. So we don't have a choice. The variables have been defined for us. Letter A says, let's begin by taking the information in the paragraph and creating a table. And of course, we just need to be careful that we're following our variable definitions. My independent variable is my t, which doesn't stand for the year. It stands for how many years have passed since 2000. When I look back up at the information, there's really only one data point given, this bit of information right here. For 2005, I'll have to record that in my table as a 5. F of t, or V, stands for the value of the stock in dollars. Well, that is exactly what they gave me, $3,000, so that remains unchanged. As far as filling in other entries in the table, I just need to read carefully. This other part says that every 4 years that went by, the value of her stock doubled. So the only way I'm going to come up with another point is to go 4 years into the future. 4 years past 2005 would be 2009. In other words, t equals 9. And the money, well, the stock used to be worth 3,000. Now it's doubled. That just means times 2. So that would be 6,000. And I can get as many rows in here as I want. Just go another 4 years. 9 plus 4 is 13. Double the money again. 6,000 times 2 is 12,000. And that's probably enough. Letter B asks, well, what kind of function is this? Well, we've only covered two kinds of functions, linear or exponential. For a linear function, I would be looking in the y column for the same number being added each time as I move down the table. I don't think that's what's happening here. For an exponential function, I would be looking for the same number multiplied down the table. And sure enough, that's what's happening. In fact, that's how we filled these in, right? We said times 2 to get from 3,000 to 6,000, and then another times 2 to get from 6,000 to 12,000. That pattern tells me that this function is exponential. Okay, now we're being asked to write an equation for this exponential function. Probably the first thing we should do is decide which case we're looking at, the easy, the medium, or the hard. So I look back at my table. Right away I notice I don't have a 0 in the t column, which means I don't know my y-intercept, so I don't know the a. The other thing I notice is that my t's are not going up by 1, which means I don't know my b. This is the hardest one, the most difficult case. Let's remember how to deal with that. I know that my final equation is going to look like y equals a times b to the x. I know we have other variable names. We'll fix that later. And in the most difficult case, all I can do is pick out 2 of the points. I'll just use these first 2 points and plug each one in to my model for x and for y. Now remember, in a minute we're going to be dividing the 2 equations. That was the trick in the difficult case, and we wanted the higher power to be on top. The power is the x. So I'm going to actually plug that second point in first, and then underneath that I'll go ahead and plug in the first point. And I went ahead and I drew in the division bar because I know where this is headed. Remember, all I've done is I've replaced the x's with the input values, and I've replaced the y's with the output values. Now we go ahead and we divide the 2 equations. 6,000 divided by 3,000 actually works out to be a nice number. It just comes out to be 2. And then remember, on the right, The A's divide out. They are common factors that disappear. And then the B's, I follow that rule of exponents about dividing two guys with the same base. The base ends up on the top, and you simply subtract 9 take away 5, which would be 4. Now I have a power equation to solve, just trying to get that b by itself. Looks like I need to take each side to the 1/4 power, the reciprocal power. That's as far as I can go by hand, and what we're generally interested in is a decimal from the calculator. There are no rounding instructions here. It's generally a good idea to keep b a few decimal places. Why don't we round b to 3 decimal places? We'll type 2 to the 1/4 into the calculator, and we get b is approximately equal to 1.189. We still need to find the value of a. Well, this is where we take the b we just got, we go back to one of the original two equations. I think I'll just pick the one with the smaller numbers. We fill in the value of b, and then we solve for a. So let's plug in that b. And then remember, I don't want to do any rounding in the middle of the problem. All I need to do to get a by itself is divide both sides of this equation by this sort of messy looking number. Let's do that. And then I've got a by itself. All that's left is to type this left side into the calculator. Again, normally there would be rounding instructions. I think in this problem we'll be safe to round our a value off to 2 decimal places. And so we get a is approximately 1,262.44. That's the end of the work. All that's left is to now fill in the values of a and b that we found into our original model. While I'm at it, let's go ahead and use the right variables. The instructions do say that we're supposed to use function notation in our answer. So in the place of the y, I will write f of t. A, we figured out, 1262.44. Times b, we figured out, 1.189. To the, normally we might write x, but in this problem we don't have x, we have t. Here is the final algebraic model for this situation. Now let's start using it. It looks like the next part is to plug a number inside here. We're being asked to find f of 15 and then explain the meaning. The finding part is fairly straightforward. Just replace that input value with 15 on the left as well as on the right. And then just reach for the calculator. There's really nothing else to do by hand here. Just type that in as it's written. You'll need a times after the long decimal number and of course the exponent button prior to the 15. And again, there should probably be rounding instructions. Let's use 2 decimal places. I got 16,940.98. As far as explaining the real life meaning of this, well, we're going to have to take into account the 15 as well as the 16,000 number. Probably be a good idea to double check our let statement, our variable definitions. Remember, T stands for the number of years since 2000, so there's going to be some year referenced here. And F of T is the money in dollars, the value of the stock. Well, the 15 is in the input position, the T position. So the 15 means 15 years since 2000. In other words, we're talking about the year 2015. The output number would be the money. This is $16,940.98. What are we saying? We're saying in the year 2015, the value of the stock was $16,940.98. Now, this next part is very important in letter E. Letter E, says that we are to explain the meaning of the b value that we got, our b value, this 1.189 that we've been looking at. We used to do this in chapter 2 with the slope. We would find the slope and we would give some sort of meaning, something like the population has been increasing by 500 people per year. Well, the meaning of the b is very similar, but take a look at this note here. It says, while linear functions change by the same amount, that 500 people each year, exponential functions change by the same percent for each unit of x. The reason for that is the multiplication pattern in the table. Remember how the y values were going times 2, times 2, times 2? When your y values multiply by the same number, it means that they are growing by a constant percent. Well, finding that percent is the key to explaining the meaning of the b, and there is a little formula here that you need to learn. It's very important. The formula is b minus 1 equals r. b here is our base multiplier, and r is that constant percent. So in my problem, I have the b value and I'm trying to find the r. I would just substitute in b 1.189 minus 1 equals r. And I get, as a result of that, r is 0.189. Now that is r expressed as a decimal. I would like to express it as a percentage, which means I need to move the decimal point 2 places to the right. And so what I get when I do that is r equals 18.9%. That's the constant percentage of change in this problem, and that's how you would explain the meaning of the b. I wrote a little sentence where we can fill in the blanks. It's very similar sounding to those old slope statements. We're going to use the word increasing or decreasing. We have the per. It's just slightly different because of the constant percent. Here's what b means. The value of the stock in this case has been increasing. We know that because our b is larger than 1. The value of the stock has been increasing by, and then what I write in here is that constant percentage, by 18.9% per, and then this last part is the same as it was with slope, that x unit. In our case, the x unit is year. If this had been a linear function, then the value of the stock would have increased by something like $1,000 per year, a constant amount. But for an exponential function, you will always be describing the change with a constant percent. That's how you need to explain the meaning of the b. Finally, letter F, we're being asked to explain the meaning of the a. Well, this is very straightforward. A is the y-intercept. Maybe it would be helpful if I wrote it as an ordered pair. That would be 0, 1262.44. Well, the meaning statement just needs to take into account the year and the money. The 0 would be number of years since 2000, in other words, the year 2000 itself. The second number would be the money, and so my meaning statement would simply be, in the year 2000, the value of the stock was $1,262.44. The y-intercept, remember, is always just some sort of starting value. So all we're saying is that in the year 2000, that was our starting year, this is how much the stock was worth. This is a typical application problem of the kind that you're going to see when you start doing the homework. If you're not sure where to begin, try to make a table, because if you can see the points, the ordered pairs, then that will help you know where to go next. And once you find the equation, then you can use it to answer the follow-up questions.